Hey pre-calc students, welcome to today's lesson on 5.7, day 2. We're continuing on with the idea of double angle formulas or identities, okay? So, it's been a couple days since we've solved equations involving trig functions. So a lot of this is going to hopefully come back to you little by little. But if after this lesson you are super confused and still need help, that is an emergency red flag that you need to come in for extra work. Okay, extra help, extra aid, whatever it takes, guys. All right, take a minute to read the directions for the first two problems. Okay, so the first thing I want you to notice is they're asking you to work within a domain of 0 to 2 pi. Okay. And they want exact simplified answers. So we are going to be also using our double angle identities, which are the ones listed above. So actually I want to do identities. Okay, our properties. Okay, so let's go ahead and get started. Let's take a look at number 1. If you notice, they're using sine of a double angle as well as cosecant of an angle. When you are solving equations, it is super critical for you to try to keep everything within the same family of trig functions. For example, everything should be sine, or all the terms should be written in terms of cosine, or everything should be written in terms of tangent. So sine and cosecant are related, okay? Now the only problem with that whole rule about like try to write everything using the same terms is that when you are only given one option for the double angle of sine, you don't have any other choice than to write. So for example, over here, right, sine of the double angle of x. That one, unfortunately, there's only one option for that to rewrite it is using sine of x cosine of x. So 2 sine of x cosine of x. That's the only way that we could write sine of a double angle. But what I was saying about this guy over here is that one is related to sine. So it's the reciprocal of sine, right? So 1 over cosecant equals sine. So even though we couldn't get all the terms to be written in only one trig function, we got as close as we could. Okay. Now this equation has different terms. They're not like terms, but you want to set it equal to 0. So the first thing that I'm going to do is I'm going to move this term to the other side using opposite signs. Okay, and by seeing it equal to 0, this is a linear binomial. Notice that it has a GCF of sine, so I can factor out a sine of x from each term. And remember that when you factor something out, it doesn't disappear. You just write it in front. All right, so at this point, there's nothing else I can factor, so I'm going to set each factor equal to 0. Which ends up giving me, for this one on the right, add the 1, divide by 2. I'm looking for where cosine of x is a half. All right, so the first part, they want to know sine of what angle will give you 0. Well, those are quadrantal angles. Sine is the y value of the quadrantal angle, so I want to know what angles have a y value of 0. Those are the ones, oopsies. So they're not the ones on the y-axis. Those are the ones on the x-axis. Here's 1, 0, and negative 1, 0. So those angles are 0 and pi. Okay, so keep that in mind, 0 and pi. All right, cosine of what angle is a half? Well, cosine is only positive in quadrants 1 and 4. My reference angle is going to be, I I should have been more specific in the directions, but I want the answers in radians, okay? So the reference angle here is pi over 3. So that would mean this is pi over 3. This would be 3 pi over 3. This, a full circle, would be 6 pi over 3. So subtract 1 pi over 3 from that and you get 5 pi over 3. So our solutions are all the angles that I'm going to highlight in yellow right now. So x equals 0, pi over 3. I'm just putting them in order. That's not a requirement, but feel free to do so and put them in order from smallest to biggest. Okay, so 0 and pi are the answers for the first half, and pi over 3 and 5 pi over 3 are the answers to this part. That looks all kinds of crazy. Hopefully you guys know where all those answers came from. And again, I'm sorry, I should be a little more specific. I kind of gave you a clue in the directions here, but in radians is how I want the answers, which is pretty much what we did in all of the first half of chapter 5. Okay, so you remember me saying that your goal is to really try to rewrite all the terms within the same family. So everything, write it in terms of sine, write everything in terms of cosine, etc. Unfortunately, with number 1, that was not possible since the double angle of sine only has one option. However, the double angle of cosine has a couple options, right? So the options are you can use cosine squared of theta minus sine squared of theta. You can use 1 minus 2 sine squared of theta, right? So these are all your options. Or you can use 2 cosine squared of theta minus 1. Now, because I do have an option that will keep everything within the family of sine, I'm going to go ahead and use that one to replace cosine of the double angle. So I'm going to use 1 minus 2 sine squared. Oopsies. Right? It's kind of weird going back and forth between the different variables, but pick one and stick to it. Okay, so I'm going to go ahead and move everything to the same side and set it equal to 0. Me personally, like I noticed that this is a quadratic term, and I always prefer to have my quadratic terms be positive. So I'm going to go ahead and move this to the left side, and it does not have a like term because it's quadratic. So you can move one thing at a time or you can do it all at once. I'm going to start organizing my terms on the left. So I put the 2 sine squared first, then the sine of x, and then the 1. But remember, we still have the 1 on the other side, which technically ends up canceling on the left when I move it over. So this is a quadratic binomial. For quadratic binomials, the only way to solve them pretty much is either factor or factor. Especially if there's a linear term. If this sine of x was in here, I could have used StatMap. So some of you used to rewrite them in simpler terms, so you can see that. They both have a term of x, so technically in this case it's sine of x. So I'm going to go ahead and factor that as a GCF. That gives me sine of x outside of the parentheses and 2 sine of x plus 1 inside the parentheses. So now I'm ready to set each factor equal to 0. And if I solve for sine of x on this one on the right, I get negative a half. So again, I'm being asked, where is sine? Sine of what angles is 0? That brings us back to 0 and pi, right? So this is 0 or 0 pi and 1 pi. So those are answers. Now, when you're talking about sine being negative, that's only going to happen in quadrants 3 and 4. But the reference angle here is pi over 6, which is 30 degrees because the sine of 30 is a half. So if this is 6 pi over 6, that means this is 7 pi over 6. If this is 12 pi over 6, then this is 11 pi over 6. So our solutions are the ones that I'm going to highlight in yellow. And you can put them in order from smallest to greatest, but that's not required. So we've got 0 or 0 pi, we've got 1 pi, 7 pi over 6, and 11 pi over 6. If you're already feeling really overwhelmed and you're not really sure how I'm doing some of these, feel free to pause, rewind, rewatch this video later, or come in for help. Okay, so do you remember that we said that there are 3 options for cosine of a double angle? Well, in this case, I'm going to try to stick within the same family of cosine. Remember, there was an option that allowed you to write the double angle of cosine as 2 cosine squared x minus 1. Okay, so I can technically replace that and keep everything else the same. Notice that if I rewrite this in a simpler term, in a simpler way, this is a quadratic trinomial. So I'm going to go ahead and arrange the terms, quadratic term first, then linear, then constant, and I need to factor this. So I'm looking for two numbers that multiply to -2 but add to 1. On your test, some of you guys did it really, really quickly in terms of figuring out what numbers they are, and your signs were wrong, so please be careful. Okay, so I'm going to split this up into a positive 2x and a negative 1x. Remember, the front and the back stay the same. You're just splitting the middle term. The GCF of the first two is 2x. GCF of the second two is -1. So those go in one of the binomials, and then the remainders should match. You get x plus 1. So replace all the x's with cosine. Set each factor equal to 0. And solve for the trig function, right? We're trying to solve for cosine. So add the 1, divide by 2. So where is cosine going to be? Positive a half. And for this one, subtract the 1. So where is cosine going to be? -1. All right, go ahead and pause the video and see if you can figure this out. What angles will have a positive cosine of a half, and what angles will have a -1 as their cosine? When you're ready, push play. All right, the reference angle for this one is pi over 3, which is 60 degrees because the cosine of 60 is a half. And cosine is positive in quadrants 1 and 4. So this will be pi over 3 and 5 pi over 3, which is right before a full rotation of 6 pi over 3. Okay, remember over here is 3 pi over 3. And the thirds are always these. Okay, so there's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so where is cosine going to be a value of -1? So this is a quadrantal angle. Cosine is the x value, and that only happens at pi, right? So here's 0, here's 1 pi. Okay, so our solutions are in order. Remember, you don't have to write them in order, but I tend to do that when there's multiple answers. Pi over 3 pi and 5 pi over 3. All right, as always, if you need any help, feel free to reach out. Have an awesome day. Bye.